Good morning, students. So today we are going to start with our fourth unit, chemical kinetics, and in this we are going to study first of all what do we mean by a rate of a chemical reaction. In this whole chapter we will be saying a rate word again and again. So what do we mean by rate of a reaction, and how many types of rates of reactions are there, and how can we determine those? Okay. So this is our topic in the fourth unit. Now first of all, what is chemical kinetics? Chemical kinetics is branch of chemistry. This is the branch of chemistry which deals with how slow or how fast a chemical change takes place. Means, in simple words, chemical kinetics is the branch of chemistry which deals with the speed of a reaction. Okay. Now see one example, here it is shown. You have seen firefly. So we are able to see light in firefly. So what is that? How it comes? So this production of light, it depends on the speed of a particular chemical reaction which occurs in its abdomen. Okay. So this light is the result of a particular chemical reaction which occurs inside the abdomen of the firefly. Okay. Now what is the rate of a reaction? Now see, we write rate of a reaction or simply we write a reaction rate. One and same thing. Both way we can write. Either we can write reaction rate or we can write a rate of a reaction. Okay. So the term reaction rate or rate of a reaction refers to the speed that a chemical reaction occurs at. What is the speed of a reaction? It tells us about this. Okay. And what other information it gives? It gives the change in amount of reactants consumed or produced. Okay. In case of reactants it will be consumed, and in case of products it will be formed. Okay, so it is change in amounts of reactants consumed or amount of products formed, okay, over a specific time interval. Okay, means what is the meaning of this line? It means that we have to see in how much time how much change has occurred. If we are taking reactants, then change will be consumption of reactants, and if we are seeing products, then it will be formation of products. Okay, so in general we can say the rate of decrease in concentration of any one of the reactant or rate of increase in concentration of any one of the product. Okay, if we are taking products, then it will be increase in concentration. If we are taking reactants, then it will be decrease in concentration. Okay, in general rate will be determined by this formula. Here delta stands for change in the quantity of what? If we are taking reactant, then also it may be, if we are taking products, then also it will be. So what is the change in the quantity? That is to be divided by change in time. Okay, so this formula will be used for determination of rate of a reaction. Now determining rate of a reaction or determining reaction rate. So see, change in concentration of reactant or product is graphed to get the reaction rate. What does it mean? It means if we want to determine the rate of a reaction, then we have to plot a graph first. So that graph will be concentration versus time. Now this concentration can be taken of reactant also and of product also. Now let us say this is a reaction A, it gives B. Then if I have to consider A, okay, then A is reactant, its concentration will decrease with the passage of time. So graph will be obtained like this. This is the graph. Okay. Now if we take B, which is a product, so its concentration will increase with the passage of time. So graph will be like this. Okay. So in whichever way we are taking, it is correct. Either we can take this blue one graph or we can take this red one graph. Okay. Now suppose we have taken blue graph, this one we have taken, then reaction rate will be like this. rate of reaction will be minus of change in concentration of A over change in time. Now minus sign indicates decrease in the concentration of A. Similarly, if I am taking this graph, B graph, then rate of reaction will be determined by change in concentration of B over change in time. Here sign is positive. Why positive? Positive sign means increase in the concentration of B. Okay. Now, how many types of reaction rates are there? So we can determine two types of rates of reaction. One is instantaneous rate of reaction and second is average rate of reaction. Now, how do we define it? Instantaneous rate of reaction means a rate of a reaction at a particular instant of time. Okay. Now, what does it mean? It means that suppose I am starting a reaction at 9 a.m. and it is completing at 10 a.m. Then if I am checking the rate of reaction at a particular instant of time, just like at 9:15 I am checking the rate of reaction, then it will be termed as instantaneous rate of reaction. Means instantaneous rate of reaction is the rate of reaction at a particular instant of time. Whereas average rate of reaction means we have to take certain time period. Say if I am taking from 9:15 to 9:30, okay, then what will be there? We have to consider the concentration at 9:15, then we have to consider the concentration at 9:30. That change in concentration between 9:15 and 9:30, that will be change in concentration, and change in time will be 15 minutes, 9:15 to 9:30. So that way, if we calculate the average rate of reaction, then it is known as average rate of reaction. Now with this graph you can see. Now I have taken this graph. As I told you earlier that we have to plot graph between concentration and time for determination of rate of reaction. So we have taken this graph. Now see, this graph is like this, so it means it is for reactants because the concentration of reactants keeps on decreasing with the time. Now let us look at this much place only this much place. Don't look anywhere else. Now what you can see in this place, we have drawn a tangent at this point. Okay, so this point is this time. Okay, now at this particular point when we draw a tangent, then we get change in concentration value this and change in time value this. Okay, we have to find out the slope at this particular point. If we find slope at this point, then that slope will give the instantaneous rate of reaction value. Now slope you know, it is y by x. So what is y? Y is this much portion is y, and what is x? This much portion is x. Okay, this much portion is x, this much portion is y. So it is written like this, dr. R stands for reactant, so this is decrease in the concentration of reactant. Okay, and this is change in time. So this ratio will give us instantaneous rate of reaction value. So in general, what we can say, instantaneous rate of a reaction can be determined by calculating the slope at a particular instant. Okay, just like in this case we calculated slope at this particular instant of time. So that value will give us instantaneous rate of reaction value. Okay, now for average rate. Now we come here. Let us put your attention here. Now we have taken 2 points. One time we have taken T1, another time we have taken T2. So whatever is the difference in this time, that will be change in time. Similarly, when T1 is the time, then this is the concentration value. When T2 is the time, then this is the concentration value. So what is the change in concentration? Change in concentration is this one, R2 minus R1. So this way we will find the average rate of reaction, where delta R is equal to R2 minus R1, okay, and delta T is T2 minus T1. This will be termed as average rate of reaction. Okay, now see, as I told you that we can take reactants also and products also. Now if we take products, then what will be the graph? This will be the graph. See, this curve shows increase in the concentration of products with time. Okay, we have again taken concentration of products and time graph. Okay, now here also we can check how to calculate the instantaneous rate and average rate. Now this is the time t, and I have drawn a tangent at this particular point. Now whatever is the slope, that is y by x, so value is dp by dt. So here it is positive. Why? Because it is for products. For reactants it is negative because their concentration decreases with time. Here it is positive because their concentration increases with time. Okay, so this is instantaneous rate of reaction. Now similarly, for average rate we have taken T1 time, so P1 is the concentration of products, T2 time, P2 is the concentration of products. So change in concentration is this much, change in time is this much. So average rate will be equal to this much. Okay, so this is what is the way to find out the average rate and instantaneous rate. Now what should be the units of rate of reaction? Now see, when we are saying that rate is equal to concentration over time, okay, so what should be there? There will be units of concentration divided by units of time. So units of concentration, if we have taken mole per liter, means molar concentration if we have taken, and time is taken in seconds, then its units will be mole per liter per second. Okay, mole per liter per second. Now if suppose our reaction contains all the gaseous reactants and products, then what will happen? Then concentration is not given by mole per liter, it is the pressure which is considered. So partial pressures are to be considered, and partial pressures have unit atmospheric. So concentration will be replaced by partial pressures. Okay, so units will be atmospheric per second. Okay, now let us solve this numerical, how to calculate average rate of reaction. Now see, in this question what is given to us? One reaction is given. This reaction is reaction of butyl chloride with water to form butanol and HCl. Okay, now for this particular reaction at different time concentration values are measured. Okay, concentration of butyl chloride was measured at different time t. Okay, this is the data given to us, and what is asked? We are asked that we have to calculate the average rate of reaction. Now you know the formula. When we have to calculate the average rate, then what we will do? We will take the difference in time. Just like if I am taking these first two readings, then difference in time will be 50 and difference in concentration will be this much, 0.1000 minus 0.0905. That will be the change in concentration. This will be change in concentration, which we can write like delta x, and this is delta t. Okay, so delta x by delta t will give us the average rate. Okay, now let us see how we have solved. Okay, now see, when we took this data, then this is the average rate. Similarly, we took any two and we found the average rate values. So average rate value is change in concentration over change in time. Just like in the very first, what we did, change in concentration, this value minus this value, this, and then change in time, this value. Okay, this way we have calculated, and the answer is 1.9 into 10 raised to power minus 4. Okay, so this way we can calculate. Now one more thing comes here. When we see this data which is obtained, then what we can find? We can note down that average rate decreases as the reaction proceeds. See, reaction is proceeding like this. It is the beginning and it is the finishing point of the reaction. Now when we move from 0 to 10,000, then average reaction rate value or average rate of the reaction keeps on decreasing. This is the decreasing value. Okay, why it happens? So what is the cause? Cause is reaction goes forward. As the reaction goes forward, there is decrease in the number of collisions between the reactant molecules. So what is to be remembered? The thing which is to be remembered is that when a reaction occurs, there is collision between the reactant molecules. So in the beginning, reactants are maximum, so collisions are maximum. With the passage of time, reactant amount keeps on decreasing, so number of collisions keeps on decreasing. So rate of reaction, that is speed of reaction, keeps on decreasing. Okay, now see, if we plot the graph, now we have plotted the graph between concentration of reactant with time. Okay, then the graph is like this. Now if we want to calculate instantaneous rate, then this is the time. At this particular point we have drawn a tangent, and we can see from the graph whatever is the value of this and whatever is the value of this. Okay, this way we can find the instantaneous rate. Okay, so this is how graphically we can determine the rate of a reaction. Okay, now again we can see, if we calculate the values, then we are able to see that rate of reaction slows down with time because concentration of the reactants decreases. So whatever value we will find here, same value we will not find here for a rate of reaction. There will be some decrease in the rate of reaction value, okay, because of decrease in number of collisions. Okay, now reaction rates and stoichiometry. Okay, now what is the meaning? The meaning is that what is the role of the stoichiometric coefficients. Now see, in this reaction, if we see here, 1 is the stoichiometric coefficient, here also 1, here also 1, here also 1. In other words, what we can say that in the throughout the reaction, if we see, then the stoichiometric coefficients are in the same ratio. Okay, there is similar ratio. If there is similar ratio, then when we have to express this in terms of rates, just like we have said that we can calculate the rate of reaction by taking concentration of any one of the reactant or any one of the product. So if I take this for determining the rate of reaction, then I will write this. Okay, if I am taking this for determining the rate of reaction, then I will be writing like this. Okay, now negative sign in this case shows decrease in concentration, positive sign in this case shows increase in concentration. Now since stoichiometric coefficients are same, here also 1, here also 1, okay, so there is no role of these stoichiometric coefficients in this case. But if stoichiometric coefficients are not same, then there is definitely great role of those things. How it is, that we will see now. Okay, now see, we have taken this reaction. In this reaction, what is there? Stoichiometric coefficient is 1, but here it is 2. Now there is role of stoichiometric coefficient. In simple words, what we have to remember? We have to remember that whatever is the stoichiometric coefficient, that should be written with delta t. Okay, just like if in this case we want to write in terms of H2, suppose, then what I will write, since it is reactant, so negative sign will be there. This is decrease in the concentration of H2 divided by delta T. Now here stoichiometric coefficient is 1, so 1 into delta T means only delta T. Okay, so no problem. In case of I2 also, there will be minus delta concentration of I2 over delta T, because stoichiometric coefficient is 1. But here in this case, when stoichiometric coefficient is 2, then how I will write? Positive sign means it is for products, so positive sign is already there. Then change in concentration of Hi over change in time, and change in time is multiplied by the stoichiometric coefficient. So what we have to say, that whatever is the stoichiometric coefficient, that is to be written in the denominator. Okay, so that is to be multiplied by delta T. This is to be remembered. Now in general, if we take this reaction where A, B, C and D are the stoichiometric coefficients, then how we will be writing? We will be writing like this. Okay, now see, this is negative sign, don't confuse in this. This is negative sign, then it is 1 by A multiplied by delta A by delta T. This is minus sign multiplied by 1 by B into delta B by delta T. Here there is no negative sign. This is 1 by C multiplied by delta C by delta T. This is 1 by D multiplied by delta D by delta T. So in other words, in simple words, what we can say, we will write the expression as it is. Only thing is, we will multiply change in time with stoichiometric coefficient of the reactant or product. Stoichiometric coefficient of the reactant or product will be multiplied by delta T. Okay, this way we have to remember it. So negative sign shows concentration of reactants decreases. Positive sign shows concentration of products increases. Okay. Now let us solve this example. What is given? The decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring the concentration of N2O5 in the solution. Initially the concentration of N2O5 is this. So initial concentration is given after 184 minutes. So this is time interval. Okay, delta T is 184. It is reduced to this. So final concentration is given, initial concentration is given. From this we can calculate the change in concentration. Okay, change in concentration, X denotes concentration. So whatever is the substance, we can write that in square brackets. That also gives us the molar concentration. So now the data is given, the reaction is given to us. Calculate the average rate of reaction. We have to calculate the average rate of reaction. Now units may be hours, minutes or seconds. In three ways we have to do it. Okay, now in minutes it is given to us. So first of all, we will write the rate of reaction for this reaction in terms of N2O5. So its stoichiometric coefficient is 2. N2O5 is a reactant. So how it will be written? Delta N2O5. Okay, minus sign indicates the decrease in concentration over delta T, and delta T will be multiplied by the stoichiometric coefficient. So this way. So how we will write? Minus delta concentration of N2O5 divided by 2 delta T. So see, minus sign is just indicative for decrease in concentration. Okay, so here when we will put all the values, then the answer will be like this. What will be the units? Here time is given in minutes. So it will be mole per liter per minute. Now we have to calculate in hours also, in seconds also. So 1 minute is equal to 60 seconds. So when we multiply, when we divide, when we put the value of minute, see, this is mole per liter divided by minute. So in place of minute, what I will write? 60 second. Okay, then I have to divide the answer by 60, and now my answer will be mole per liter per second. It will be in mole per liter per second. Okay, Now when I have to calculate for hours, then we know 1 hour is equal to 60 minutes. So it means 1 minute is equal to 1 by 60 hour. So what I will do, when I have calculated this value in minutes, then I will multiply this by 60 and then our answer will be in hours. So when I will multiply with 60, then I will get this answer. Okay, so hours, minutes and second, this can be calculated. Okay, now the question is, what is the rate of production of NO2 during this period? Now rate of production of NO2 is also to be calculated. Now see, in this balanced equation, 4 is the stoichiometric coefficient. So how we will write? See, rate we have calculated. Rate is equal to 1 by 4 times change in concentration of NO2 over change in time. Okay. Now this is to be calculated. This thing means rate of production of NO2. So whatever is the rate value, that will be multiplied by 4 and we will get delta NO2 over delta T. Okay. So this way we can calculate it. Now whatever we have discussed today, on the basis of that you have to do these home assignments. Okay. Thank you.